Okay, let's continue where we left off. Now we're going to talk about section 3.4. Look at more applications on annuities. So first one, let's go review on the annuity formulas. We have two types of annuities. First one is future value of the annuity. And we also have present value of the annuity. First one, let's review the formulas. Future value of annuity. So here we have future value equal regular payment times square bracket parentheses 1 plus annual interest rate over number of compounding period raised to nt power minus 1. And dividing by the denominator is annual interest rate over number of compounding period. So it's mainly used for the retirement account of trust fund. So if you look at the future value of the annuity, F represents future value of annuity, R represents regular payment or PMT, lowercase r represents annual interest rate, and lowercase n represents number of compounding periods per year, and then t represents time in years. Okay. So we're going to use this formula, future value of annuity. Also have present value of annuity, P equal to regular payment times square bracket 1 minus 1 plus rate annual interest rate over number of compounding period close parentheses raised to negative nt close square bracket over r of n. It's mainly used for saving account, mortgage, car loan, credit card, student loan, all those financial instruments. Okay, so now one more time, let's review all these symbols. P represent present value of the annuity, R represent regular payments or the PMT, and then lowercase r represent annual interest rate. Then we have N represent number of compounding period per year, T represent time in years. Okay, so we use this to handle some of the annuity problems. So, and in the previous section, we talked about zero coupon bond. And zero coupon bond is a special type of bond, meaning they do not pay interest or dividend. Investors just get a deep discount when they purchase the bond, but for most bonds, they do pay dividend based on the market rate or fixed interest rate from the market. And we now have the skills to price this kind of the bonds. So we have two types of discount process. First one is discount the par value of face value, meaning we find the present value of the par value. And the way how we do it is using a compound interest formula. Meaning we are using future value or present value times 1 plus rate over number compounding period raised to nt. We are solving for the present value of the par value. That's first step. Second step, we discount the series of the dividend. And series dividend give us annuity. Lump sum payment, that's at the present time, right? So as a bondholder, you want to figure out how much the series of dividends is worth right now. So we are using the present value of annuity formula to find out the present value of all the dividends. And so once we complete both process, combine the bond price from both sources, and we end up with the final bond price. Now let's take a look at one of these examples about pricing a bond. Example 1, what will be the price of the bond with the 10,000 par value that will mature in 10 years that yields 4% dividend. So this 4% dividend is it's also called coupon rate. It's So the interest payment or dividend is based on the dividend rate, and it's paid yearly. So we have two processes. First process is discount the par value. So par value is $10,000. We're going to discount at $10,000 using compound interest formula. So $10,000 is investor will get it, or bondholder will get it in 10 years. So that's a future value of $10,000. We also know the rate. So rate is based on the market rate. We call this fixed interest rate based on the market condition. And this rate actually is average return for all the bonds in the current market. So rate here is 6%. When we do the discount process, we're using the market rate. And 90 for 10 years. The compounding period is once per year. So now we're looking solving for present value of this par value. So future value for present value. Now we throw in the future value 10,000. It's off of the present value. So this is 1 plus the rate is 6%. And the compounding period 1. And this is 1 times 10. So if you simplify a little bit, we get 10,000 equal present value times 1 plus 6% to the 10th power. Now from here, the present value will be equal to 10,000 over 1 plus 6% to the 10th power. And that's how we figure out the present value of the par value. So now we're going to use Excel to do this. One more time, let's open Excel. So equal to 10,000 dividing by 1 plus 6% raised to 10th power. Okay. And if you key enter, you get a bond price from the discount of the par value. So this is $5,583.95. $5,583.95. Okay. So this is first source, and then we also have second source, which is discount of the dividends. So first one, we need to find out how much is the dividend. Dividend is 4% based on $10,000. 4% at 0.04 times 10,000. That turned out to be $400. Meaning, as an investor or bondholder, you're receiving $400 interest payment every year. Okay. So this is what we call a regular payment, $400. And you're receiving that amount for 10 years. And then the market rate is 6%. We discount it using the market rate. And then number of compounding periods is 1. So now we try to find out the present value of all those dividends, right? So present value of all dividends using annuity formula 1 minus 1 plus our n negative nt over our value. I'm throwing all the numbers. So this is 400 times 1 minus 1 plus the rate is 6% over 1 raised to negative 1 times 10 over 6% over 1. If you simplify a little bit, you get this. So this is 400 1 minus 1 plus 6% raised to negative 10 power dividing by 6%. Let's see what that is. Again, we're going to use either calculator or Excel to do this. So let's go to the Excel. So this is equal to $400 multiplied by 1 minus 1 plus 6% raised to negative 10 power divided by 6%. And then if you enter, you get a result. So this turned out to be $2,944 and then cents. $2,944 and 3 cents. And if you combine those two sources, you get a bond price. So you combine the sort of the final bond price is adding those two amounts, $5,583.95 plus $2,944.03. And the total is the bond price. The total is how much the investor have to put down in order to hold a bond. So the total is 5583.5, adding 2944.3. The total is $8,527.98. 527.98. Okay, so this is the bond price. Okay. All right. So two-step, step one, step two, just separate them, do it step by step, use the right formula, we get a result. Example 2, 8,000 bond that matures in 20 years has a coupon rate of 5.25% payable yearly. Okay, so that this is the coupon rate. The bond is priced to yield 6.58% according to the bond market. What is the price of the bond? Similarly, two steps. Step one, discount the par value. So we'll do so here the $8,000 bond, so future value of the bond is $8,000, and then the market rate is 6.58%, which is 6.58, 6.5%, 6.5%. So 6.625%. So if turning into a decimal number, it's easier to move forward. And time t, that's going to be 20 years. And the compounding period is 1 year. And again, we're looking for the present value of this par value. So it's present value times 1 plus r over n times t. So future value is 8,000. Plus the rate is 6.625% over 1 to 1 times. One more time, we simplify 8,000 equals present value times 1 plus 6.625%. Now the present value of this equal to 8,000 over 1 plus 6.625% to the 10th power. Let's see what that is. So one more time, we use the Excel to get this. So this is 8,000 divided by 1 plus 6.625% and raised to 1 power, and equals 20 years. So this turned out to be $2,217 and then 2217.73. 2217.73. And this is the bond price from the discount of the par value. Second step, discount the dividends. And step one, we need to find out how much is the dividends. So dividend is based on 5.25% dividend equal to 5.25% times 8,000. Okay, one more time, this is 20. That's 20 here. So that's a typo, this is 20, not 10. 20 power. I use the right exponent and calculate the present value. So 5.25% times 8,000. 5.25 is 5.25%. 8,000. This turned out to be $420. So the dividend payment is $420. Yeah, let me just double check, make sure this number is right. So we get a 5.25% times 8,000, and that's $220. It's good. Now from here, we know this is regular payment, dividends regular payment, payable yearly 120. The market rate is 6.58%, which is 6.625%. Time t equal 20 years, and the compounding period equal to 1. So looking for the present value of the annuity. So present value equal regular payment times 1 minus 1 plus r over n to negative t over r over n. Now one more time, we're throwing all the numbers. So 520 times 1 minus 1 plus 6.625% over 1 raised to negative 1 times 20. And dividing by 6.625% over 1. And if you simplify a little bit, you can omit all those ones, and let's get a result here. So let's put into Excel. So this is 420 multiplied by 1 minus 1 plus 6.625% raised to negative 20 power. Close parentheses divided by 6.625%. And that should do it. We get the bond price from the discount of par values, the dividends. So it's $4,582.17. $4,582.17. Double check the number. It's good. So now from here, when we combine these two sources, so the bond price is $2,217.73 plus $4,582.17. This total becomes the final bond price. So combine them, we get $2,217.73 plus $4,582.17. And the total turned out to be $6,799.90. $6,799.90. $6,799.90. So that's a final. And so the standard process, just discount par value, discount the dividends, and get a final bond price. Example 3, consider the price of the bond. Example 2, if the bond is not priced to yield 4.75%, assuming everything else is the same. So still two-step. First step, discount of par value. The only thing is now the market rate changes, right? Market rate becomes 4.75%. Look at the previous one, it's 5.25% now. It's 6.58%. Now it's 4.75%. So same thing, future value of the par value is $8,000. Time t, that's 20 years. Now the compounding period is 1. The rate is 4.75%. We just want to compare if when the market rate changes, how the bond price changes. But again, we're using the future value for the present value. R over n to the nt. Future value is 8,000. Present value is 1. The rate is 4.75% over 1 raised to 1 times 20. Then we simplify 8,000 with present value of 1 plus 4.75% to the 20 power. And present value equal to 8,000 over 1 plus 4.75% to 20 power. The bump price from the par value, let's use Excel to get a result. And this should be 8,000 divided by 1 plus 4.75%, close parentheses, raised to 20 power. Okay, so the lower rate, meaning when the market yield is lower, investors getting less interest, they have to pay more, right? They're getting less interest, less dividend from that, so they have to pay more. $3,162.35. So this turned out to be $3,162.35. So this is the discount of the par value. All right, now we're gonna look at the discount of the dividend. The second step is find the discount of the dividend. So now dividend amount should be the same, right? So dividend is, the rate is 5.25% payable yearly, 5.25% times 8,000. This is 5.25% times 8,000. So this turned out to be $420. Dividend amount is the same, so regular payment is the same, $420. The rate, it's 4.75% now. Number compounding period 1 times t equal to 20. Now we're looking for present value of the annuity, so it's regular payment times 1 minus 1 plus R into t over R. So this is 420 multiplied by 1 minus 1 plus. Since n is 1, you can just omit it. Just write out 4.75% raised to -1 times 20 is -20. And divide by 4.75%. Let's see what the present value of that. So one more time, go into Excel. So this is 420 multiplied by 1 minus 1 plus 4.75% raised to -20 power dividing by 4.75%. And then that will give us a discount of the dividends. And this turned out to be $5,346.88. $5,346.88. And then when we combine both sources, so the bump price, let's combine them. $3,162.35 plus $5,346.88. So total bump price, let's see, so $3,162.35, adding $5,346.88. Okay, the total is $5,809.23, 8509.23. Okay, so the investor is paying more, right? Because the market rate is lower, meaning the average return on all the bonds are lower. So from the example 2, investor only paying $6,799.90. Then for 3, they are paying $8,509.23. So they are paying more for the bond. Okay, so example 4, it's about credit card debt. So most people have credit cards, and sometimes when they receive the statement from the credit card company, it's hard to keep track of that. But once we learn this compound interest concept, we'll be able to solve this. You have $6,000 balance on your credit card, which carries 18.99% interest rate. So this is annual interest rate. You pay off $1,000 and charge $425 15 days before the next settlement date. Settlement day is like statement date, right? What is the bill on the next month's statement? So the bill comes from 3 sources. First source is unpaid balance from $6,000. So it will be 6,000. You pay off $1,000, and then since you pay off $1,000, that means you only have $5,000 balance left, and then you have to pay the interest for 1 month, right? And monthly interest will be 18.99%, yearly interest by 12. So you pay interest on $5,000 balance, and third source is coming from the new charge. So new charge is $425, and you're still paying half month of interest because it's 15 days before the next settlement date. So you borrow the money for 15 days, that's half a month. So it's 18.99% over 12 times half. Okay. So we combine all the 3 sources, that's the statement bill on the next month's statement. So it's 5,000. We can simplify, so this is 5,000 times 18.99% over 12, and then plus $425 times 18.99% over 24. So combine all 3 sources, we can get a total statement balance for next month. So here, let's add up those 3. So $5,000, that's the unpaid balance from previous month. And also you gotta pay $5,000. The interest on that 18.99%. 1 month interest, monthly payment. Adding, so new charge $425. You gotta pay half of the monthly interest, 18.99% by 24. And then combine all those 3, that will be the new statement balance. Again, since it's money, so we run it through decimal place, $5,082.49. $5,082.49. So this is total statement balance for next month. And this credit card. Alright, so example 5, we have a balance of $13,500 on your credit card bill, which charges 19.99% per year interest. You want to pay it off in 3 years with equal payments. Now, this sounds like annuity. Equal payments tells us this is annuity, and we have long sum here. How much must you pay every month to do this? How much total interest will you have to pay? So actually, this monthly payment is what we call the regular payment, right? So we're looking for the regular payment. Now this is present value. $13,500 debt is at the present time. Right? So we're using present value of the annuity formula. So the present value is 13,500 times T, that's 3 years. And and equal payments each month, monthly payments. So number compounding here is 12. The rate is 19.99%. And then we are solving for regular payment. So present value of annuity equal to regular payment times 1 minus 1 plus our n over our. Okay. Now throwing out the numbers into this formula, we get 13,500. Regular payment times 1 minus 1 plus the rate is 19.99% over 12 raised to negative 3, 12 times 3, 3 times 12, same thing. And then dividing by 19.99% over 12. And as I mentioned from last time, we can do this. We can make it proportion, and we saw it from there. We cross multiply. So r times the square bracket 1 minus 1 plus 19.99% over 12 raised to negative 36 power. So you have to make 36 payments over the life of the credit card debt. And then on the right hand side, that's 13,500 multiplied by 19.99% over 12. Now dividing square bracket from both sides of the equation, 1 minus 1 plus 19.99%. 12 raised to negative 36 power 1 plus 19.99% over 12 raised to negative 36 power. So we cancel the square bracket. It's a regular payments by itself. Let's see what the regular payment is. Let's go to the Excel. The result. So this is 13,500 multiplied by 19.99% by 12. Numerator divided by denominator 1 minus 1 plus 19.99% 12 raised to negative 36 power. Okay. Then we enter the result. The result is $501.64. $501.64. All right, so now next step is find out the total interest paid. So this is regular payment. So total interest paid. So you're paying $501.64 with 36 payments, but you only own $13,500. So the additional payment beyond $13,500, that's what we call the interest paid to the credit card company. So this is 501.64 multiplied by 36 minus 13,500. The difference is the interest payment. So we are paying about $4,599, $59.04. $4,559.04. That's just basically the interest charge, right? And paying interest, there's no benefit for the credit card holder, which means it doesn't benefit the credit card holder. Example 6, the person in example 5 transfers the account to a card charging 5.99% interest per year. So this is what they call balance transfer. A lot of time, other credit card companies will send you this balance transfer option. They will charge you less interest based on lower interest rate, but also they actually will charge a one-time payment or something like that. So if it is worth it to transfer the balance, you do it. Otherwise, you stick with the old credit card company. So let's see if this is worth. So now, how much will the equal payment, monthly payment, be to retire the debt in 3 years. So everything else is the same except the interest rate, right? So they only charge 5.9%. So now one more time. These are the given information. The home present value annuity is 13,500. I'm still looking for the regular payment. And is our compounding period 12 a year. The rate now is different, 5.9%, which is a lot lower compared to 19.99%. So we do expect to have a lower regular payment. Let's see if that's the case. Because interest rate is lower. So present value of the annuity for regular payment is 1 minus 1 over n over our. Now one more time, we're throwing on the numbers 13,500 regular payment as we're looking for 1 minus 1 plus 5.9% over 12 3 times 12, 36 payments, and then it's 5.9% over 12. So the proportion cross multiplying and solve for the regular payment here. So regular payment and square bracket 1 minus 1 plus 5.99% by 12 and raised to negative 36 power and equal to 13,500 times 5.99% 12. Okay. And now we divide square bracket from both sides of the equation. We cancel that square bracket, so we find out the regular payment. Let's see what that is. One more time. We put it back here. So this is 19.99%. Right now we're looking at 5.9%. So it's 13,500 multiplied by 5% by 12. Divide by 1 minus 1 plus 5.99% by 12 raised to negative 36 power. Those parentheses. Let's see what that is. And this turned out to be $410.63. As you can see, the monthly payment is much lower. It's only $410.63. Total interest paid. We assume it will be much lower. Okay, but yeah, let's see. $410.63. So the total payment, let's see what was the total interest paid. So as a credit card holder, you pay $410.63 for 36 times. And you only owe $13,500. So the difference is the interest paid to the credit card company. Let's see how much that is. Okay, so we do 410.63 times 36 payments minus 13,500. So the difference is what we call the interest paid. As you can see, it's much lower. So basically saving about $3,300 by switching to a new credit card, right? Which is a lot better off. You're saving a lot of money by switching the cards. 1282.68. So you should definitely switch, right? In this case, these option balance transfer options available because you're saving yourself $3,300 approximately by switching the credit card. And the term is called balance transfer. Question 7, it's about amortization schedules. So we talk about mortgage from last section, and now we're going to take a look at how we amortize the mortgage. We're going to show the detail, schedule, like how much interest paid, how much principal paid, and I'm going to show you how to do that in Excel in a second. But first of all, let's find out the regular payments, monthly payments, right? So this mortgage is what we call the present value of annuity. So you borrow 300,000 from the bank. This is present value. You're getting a big check right now, 300,000 from the bank. And it's a 30-year fixed mortgage with 5% interest. And we want to find our regular payments. So here, present value of annuity is 300,000. And then it's a 30 years, so 20 for 30 years. And then number component is monthly payment. Rate is 5%. And we want to create first 5 payments, right? Just first 5 payments. Now, let's look at this. So first of all, let's find out the regular payment. Present value of annuity equals regular payment times 1 minus 1 over n T per hour. And putting all the numbers, 300,000 for the regular payment, 1 minus 1 plus 5% over 12, raised to 12 times 30, 360 payments of the life of the mortgage, 5% over 12. The proportion, and we will end up with regular payment times square bracket, 1 minus 1 plus 5% over 12, raised to 360 power. Right hand side 300,000 multiplied by 5% over 12. Now dividing both sides of the equation by square bracket, so regular payment equal to 300,000 times 5% over 12, dividing by 1 minus 1 plus 5% over 12, raised to negative 360 power. Let's see what the regular payment is. So again, I'm putting Excel right here. Okay, so also I'm gonna create a new sheet. I'm gonna show you how to do this right here. So first one, let's find out the monthly payments here. Okay, all right, so monthly payment equal to 300,000 multiplied by 5% by 12, numerator divided by denominator, 1 minus 1 plus 5% by 12, raised to negative 360 power. And then its monthly payment come out to be $1,610.46. 1610.46. All right, so now let's create an amortization schedule. And just summarize everything we have here. First of all, so the original principal amount is 300,000. Okay. And then we also the rate, that's going to be annual interest rate. Annual rate, that's 5%. Okay. compounding period A. So now we just list all this information. Now we start creating the amortization schedule. So so we start with the payment number. So we start with payment number 0, 1, 2, 3, 4, 5. Okay. And we only need 5 payments, and we need to figure out how much interest paid. After each payment, interest paid and principal paid. Then after that is the remaining principal, the remaining balance. And this table is what we call the amortization schedule. I'm going to just put it into the table form. Fully center, put all borders here. Okay, and we can get started on this. Right. First of all, let's find out the. So missing one more thing. Which is I'm going to show you in a second. It's a payment amount. So this payment amount. Okay. So the payment amount remains the same. It's $1,610.46. Okay. I'm putting dollar sign for all of this. And this one remains the same. I'm going to try to get all this same. So no, first payment number 0, they do not pay anything. So this is 0, right? $0. Okay. Interest pay 0, principal pay 0, and remaining balance will be 300,000. Okay. So now, after paying the first payment, we can find out interest paid first. Interest is based on $300,000 because you're not paying anything yet. And then we are paying 5% by 12. Monthly interest, right? 5% by 12, that's monthly interest. Get that. So the interest paid for in this payment, interest paid is $1,250, but you're making $1,610.46. So the principal paid here will be difference. Total payment minus interest paid. So it's always easier to find out interest paid first. That's $360.46. Now remaining balance is going to be 300,000. Older balance minus principal paid. So principal paid is used to reduce the remaining balance, 46. So now once get to the second payment, now our remaining balance $299,639.54 multiplied by 5% over 12. So you're still paying the 1 month interest based on the remaining balance, and this turned out to be $1,248.50. As you can see, interest paid go down, meaning principal paid will go up. So this is $1,610.46 minus $1,248.50. Okay, so we get $361.96, and this principal paid is used to reduce the remaining balance. So we go 299,639.54 minus $361.96. Okay, so we get that. So again, the remaining balance goes down as well. So now, since the remaining balance goes down, we are paying less interest. 299,277.58. So the monthly interest is based on remaining balance 5% by 12. So now the interest paid is 1246.99. So that means we pay more towards the principal. So 1610.46 minus 1246.99. Yes, so you're paying $363.47 after the third payment. So the remaining balance will be $299,277.58 minus $63.47. It's probably to be $298,914.11. Now, for the fourth payment, the interest is based on the remaining balance, updated remaining balance times 5% by 12. Get that? So the difference between the total payments 1610.46 minus 1245.10, 0.48. And then so the principal paid becomes slightly bigger. So now remaining balance is 298.14.11 minus 364.98, and the difference is the remaining balance. So now interest paid then is based on the remaining balance 298,549. 13 minus times 5%, 12. So basically, you can create the full schedule. That's what the bank is doing. When you apply for the mortgage, once you approve it, they usually provide this to you, but you can verify all the numbers yourself. So it will be 610.46 minus 1243.95. Yes, so you're paying slightly more principal. So eventually, the principal is remaining balance will be paid off. So 298.49.13 minus 366.51. So that's how you end up with the ending balance. And you can keep going until you reach all 360 payments. Right, so this is what they call amortization schedule. It shows you breakdown of the interest paid, principal paid, and then you can calculate how much total interest you paid over the life of the mortgage by sum up all this interest paid. Okay. So now this is the first scenario is 30-year fixed mortgage, right? 20 for 30 years. Now let's take a look at 20 here, right? It's 30 years. Now the other example is 15 years. And we can compare them, which one is better off, the trade-off of these. Now let's go back to the component. So now the last example 8, consider you take out same amount of mortgage, 300,000, but it's 15 years mortgage with 5% interest. Now the term becomes half of it, and it's 5%. Right? So now one more time, we need to calculate the regular payment first. So present value annuity, 300,000 for $300,000, 29 for 15 years. For compounding period is 12, the rate is the same 5%. Now still solving for regular payment. Let's write down the formula first. And one more time, we're plugging all the numbers. 300,000 regular payment times 1 minus 1 rate is 5% over duration over 12 times 15. For 15 years fixed mortgage, you are making 180 payments. 180 monthly payments. So this is 5%. So one more time, we will solve for R. So using the proportion times 1 minus 1 plus 5% over 12 raised to negative 180 power. Now on the right hand side is 300,000 multiplied by 5% over 12. Now we're dividing square bracket on both sides. Then we cancel that. So regular payment is by itself. Let's figure out how much is the regular. So here, I'm going to create a new sheet here. So I'm going to copy all of this because we're going to use all these numbers one more time. I'm going to copy put in the sheet 2 here. So we can compare that in a second. Let me just modify something here. Okay. We're still working on the amortization schedule, so I'm going to delete all of these numbers for now. And again, it's now it's 15 years fixed mortgage. Monthly payments, we're going to calculate that right now. So let's see. 300,000 multiplied by 5% by 12 dividing by 1 minus 1 plus 5% by 12 makes negative 180 power close parentheses. And let's see what the monthly payment is. He entered, we get $2,372.38. So paying a lot more, right? $2,372.38. Okay, so this is regular payment. Now one more time, we will create an amortization schedule in Excel. So for payment number 1, we did not make any payment. So payment number 2, payment number 1, no. Payment number 0, we do not make any payment. Payment number 1 will be $2,372.38. And then the payment amount is the same for 480 payments. So now, first of all, let's calculate the interest. As you can see, the first interest will be the same. So it's going to be 300,000 times 5% by 2. So paying the monthly payment, monthly interest is $1,250. And if you look at the principal paid, you're paying total payment is $2,372.38. You're paying $1,250 towards the interest. So the principal pay is a lot more, right? That means you are paying the pay off the balance much quicker because you contribute towards more on the principal paid. Okay, so this is 300,000 minus $1,122.38. So the remaining balance go down a lot quicker. And now for the second payment, you're paying interest based on the remaining principal or remaining balance. 5% over 12. Right. The rate remains the same. So paying less towards interest. So now 237.38 minus 1245.32. And then the principal paid $1,127.06. That is used to reduce the remaining balance. 877.62 minus principal paid after second payment. So you see it goes down a lot quicker. Now by the time we get to the third payment, you're paying monthly interest on remaining balance multiplied by 5% over 12. And here actually we get that interest paid. Now the principal paid will be the difference. Anything you sell, right, minus this, get that. Now it's used to reduce this balance, so this minus this balance, we get that. Okay, remaining balance. Now we are paying monthly interest on the remaining balance. We use sale to represent the remaining balance here, so this cannot. Now again, total payments minus interest paid. That's the principal paid in this period. So now the remaining balance is the beginning balance minus principal paid. That's that. Now one last thing is paying the monthly interest on the remaining balance. So now similarly, the interest paid goes down, principal paid goes up. So this is this minus interest paid, that's principal paid. Now the remaining balance after the fifth payment turned out to be 294,000. Compared to the previous one, after 5 payments, still 298,000. So the payment amount is much more. The principal pay is much more as well. So you pay off the balance much quicker. So this is what we call amortization schedule. Many used to show the detail, information on how much interest paid and principal paid. You can play around with it. Excel, a quicker way to solve it in Excel. And also work on homework assignments and get better at this.